So today we're going to start applying our knowledge of exponent properties by using scientific notation. So your goal by the end of today is that you can convert numbers between standard form and scientific notation, and then that you'll be able to perform multiplication and division on scientific notation numbers as well. So to start, let's talk about standard form. And most of you don't realize this, but the numbers that we use in everyday math are in standard form. So if you have a number like 53, or a number like negative 172, or a number like negative 0.00015, or 0.00867. All of these numbers are written in what's called standard form. It's the standard form that we typically use with numbers. And what we're going to talk about today is how we can take these numbers that we know written in standard form and convert them into scientific notation. Now, hopefully you've seen scientific notation before, but if you haven't, all of the numbers written on the screen are currently written in scientific notation. And I want you to recognize a couple of the similarities that they have. First, what you'll notice with all of these is that it always goes number, decimal point, and then the rest of the digits. So you'll notice that here it's 1 decimal point, 9 decimal point, 3 decimal point, -5 decimal point, -4 decimal point. So there's always exactly one number before your decimal point. The second piece is that it always has a times 10 to the power of blank, times 10 to the power of blank, times 10 to the power of blank. You can see that in all of these. So it's always going to be some number times 10 to some power. So that's how scientific notation numbers are written. You always have one number before your decimal point, and then it will be a number times 10 to the power of blank. And we'll talk about how we convert numbers from standard form into this form in just a minute. So in order to begin converting numbers from standard form into scientific notation, the first thing we need to note is that the numbers written in our number system are of base 10. So we know that this is the ones position, the tens, the hundreds, the thousands, the 10,000s, and so on. And because of that, we can use powers of 10 to help us convert this into scientific notation. So the first thing we note is that to be written in scientific notation, it needs to be number, dot, and then the rest of the number. So only one number comes before that decimal point. Right now our decimal point is all the way back here. So what we're going to do is we're going to essentially move that decimal point so that we can then write it in terms of powers of 10. So here when we move the decimal point 1, that would be 10 to the power of 1, 10 to the power of 2, 3, 4, 5, 6, 7. So really what's happening here is as I move the decimal point, so here I can now write 4.289, can write it times 10 to the power of, notice I moved it 1, 2, 3, 4, 5, 6, 7 spaces. So it would be times 10 to the power of 7. Now when you realistically think about this, 10 to the power of 7 is a very, very, very large number. And if we were to multiply that out, that would be a 1 followed by 1, 2, 3, 4, 5, 6, 7 zeros. So we can see that's 10 million. And when we look at that, 4.2 times 10 million, well, that makes sense that that would get us back to the 42 million we see up above. So all we're doing is rewriting this in a different way and using the power of tens to help us represent that number. So 4.289 times 10 to the power of 7, which is 10 million. So instead of writing this as 42 million, I'm writing it as 4.289 times 10 million. Now if we look back at this next one, we're going to move the decimal point in the opposite direction. So we're going to move it 1, 2, 3, 4, 5 positions. So we have 5.74 times 10 to the power of, and we need to figure out what's going to go up here. Now it wouldn't make sense to have a positive exponent here because that would make 5.7 bigger. If it was even just 10 to the power of 1, 5.74 times 10 would give us 57. So that tells us that we're going to have a negative exponent up above. So notice how we move the decimal point 1, 2, 3, 4, 5 spaces, and that tells us that we're going to have 10 to the power of negative 5. And again, if we think about what 10 to the power of negative 5 really is, that's a very, very, very small number. That's 1 over 10 to the power of 5. Remember, we're using those properties from last section. And so that's really 1 over 1 followed by 1, 2, 3, 4, 5 zeros. So what we're saying is we're taking 5.74 and we're multiplying it by 1 100,000th, which makes sense. We're going to make it significantly smaller. So notice how when we multiplied by 10 to the positive power, that represents a very, very large number. And when we multiply by something that's 10 to a negative number, that represents a very, very small number, a number that's very, very close to 0. Now, if these numbers are negative, it's the exact same process. We're going to plot the decimal point and move it 1, 2. So I have negative 9.68 times 10 to the power of, I moved it 1, 2. So this would be negative 9.68 times 10 squared, which we know 10 squared is 100, so that makes sense. Notice how if we have a negative number, the only difference is that there's a negative out in front. Now here, the same process, I move it 1, 2, 3 spaces, so I have negative 2.65 times 10 to the power of, I moved it backwards, 1, 2, 3, so that would be negative 3, and that would then be negative 2.65 times 10 to the power of negative 3, which remember is really 1 over 10 to the power of 3, or 1 1,000th. Okay, so now we're going to do this in reverse. Here we have numbers that are written in scientific notation, and we're going to convert these into standard form. Now, if you ever forget how these work, take a look at the power of 10 that you are dealing with. So here we see 10 to the power of 9. Well, I know that 10 to the power of 9 is 1, followed by 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. That's a very, very large number. So I anticipate that that number is going to be very, very large once I multiply it out by powers of 10. So on the previous slides, we moved the decimal point over, so it would be number, decimal point, and then the rest. And now we're going to essentially undo those changes. So we know we would have moved the decimal point 9 places. So now I'm going to move the decimal point 9 places, simulating this multiplication of this very, very large number containing 9 zeros. So here I'm going to move it once, 2, 3, 4, 5, 6, 7, 8, 9 spaces. And everywhere where there's an empty space, where I didn't have a number still, I put a 0. So 1.2 times 10 to the power of 9 is 120, 0, 0, 0, 0, 0, 0, 0, 0. So it's a very, very large number, which makes sense when you're multiplying 1.2 by something like 10 to the power of 9. Now we're going to reverse this as we look at the next one. So we have 10 to the power of negative 8, which tells us that we're multiplying by something that's very, very small. This is 1 over 1 followed by 8 zeros. So we know that as we multiply this out, that negative 5.72 is going to become very, very small. So here I'm going to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to have 0.1, 2, 3, 4, 5, 6, 7 zeros. Followed by 5, 7, 2 with that negative sign in there as well. So converting between the two isn't hard. You just really have to think about what these powers of 10 with positive exponents versus negative exponents really mean. So if there's no decimal point, this really isn't any different. You just have to simply write in that decimal point. So here we know it would be negative 8 followed by a decimal point, so we write that in. And then because this is 10 to the power of negative 3, we know that this number is going to become very small. So we move that decimal point over 1, 2, 3 spaces. So I'm going to have 2 zeros in there, so it becomes negative 0.008. And then here, same thing here. We put that decimal point in, Because I'm multiplying it by 10 to the power of 2, I know that that's going to make it larger because 10 to the power of 2 is 100. So I'm going to take a decimal point and move it 1, 2. So I get negative 400. Okay, so this last chunk we're going to talk about multiplying numbers with scientific notation and then dividing numbers with scientific notation as well. So just like we looked at last chapter, when you're multiplying numbers with scientific notation, I like to rewrite this. So I have the numbers that are being multiplied. So I have 5 times 1.6, and then I have the powers of 10 next to each other as well. So here we have 5 times 1.6, which I know is 8. And then I have 10 to the power of 9 times 10 to the power of 3. And I know that because these have the exact same base, that I can simply add their exponents. And 9 plus a negative 3 leaves me with 6. So I'm going to have 8 times 10 to the power of positive 6. Now from here, I'm actually going to leave this in scientific notation. For most of the problems you'll see like this, I will ask you to leave your answer in scientific notation, especially since you don't have a calculator. So leaving your answer just like this would be perfectly fine. So dividing is going to work just as you would expect it to. We start by just dividing out those numbers. So here we can see we have 12.4 divided by 3.1. If I do that, I end up with 4 over 1, and then I have 10 to the power of negative 8 in my numerator and 10 to the power of negative 2 in my denominator. Then from here, in order to combine those bases together, I'm going to actually move the negative 2 up. And remember, when we ask something to switch sides of the fraction, the exponent changes to the opposite sign. So as we move that 10 to the negative 2 up, that's going to become 4 times 10 to the power of negative 8, but then times 10 to the power of 2. So noticing that we're using those properties that we used last section. So then from here we can combine. We know that if we have two numbers with the same base that are being multiplied, we can add their exponents. So this becomes 4 times 10 to the power of negative 8 plus 2 is equal to negative 6. So lastly, we're going to look at what happens when we get an answer that's not written in perfect scientific notation. So to start, let's look at multiplying 3.5 times 9.4, which gives us 32.9. And then we have times 10 to the power of, well, I can see I have 10 to the 6th and 10 to the 9th. Those are the same base with exponents that we can add together. So that becomes 10 to the power of 15. Now, some of you are looking at this going, yep, looks good. It looks like scientific notation. However, remember that scientific notation is one number, decimal point, and then the rest. And if you look at this particular problem, we have two numbers instead. So what we're going to do is we're going to rewrite 32 into its scientific notation equivalent. And I know that if I move that decimal point over 1, that it will be in perfect scientific notation. So here I'm going to take my decimal point and move it over 1 and rewrite it as 3.29 times 10 to the power of 1. And that makes sense. 3.29 times 10 would give me 32.9. Now from here, don't forget that we multiplied that 32.9 by 10 to the 15th. And then from here, we can simply combine those 10s again. So we get 3.29 times 10 to the power of 16. So as you work through these types of problems, just make sure that your answer is written in perfect scientific notation, and if not, you'll need to use your knowledge to rewrite it. Now if we look down at the bottom one, we start by dividing out the 4 and the 16, and if we divide out the 4 and the 16, we know that that simplifies down to 1/4, which becomes 0.25. Then if we look here, we want to move this 10 to the power of negative 5 up, and as we do that, this becomes 10 to the power of 4 times 10 to the power of positive 5. So remember that the sign here changes to a positive. So then from here, we're going to combine those bases of 10 together. So I have 0.25 times 10 to the power of 4 plus 5 is 9. And now when I look here, this looks very, very close to scientific notation, but I note that there's not a number before that decimal point. So I need to move it over 1. And as a result, I rewrite this chunk, this 0.25, into scientific notation, which becomes 2.5 times 10 to the negative 1. And then we still have that times 10 to the 9th. And then we can simplify that just a little bit more to be 2.5 times 10 to the 8th.